Good evening. Thanks for coming to Milwaukee's Climate Summit. As she said, I'm Mark Gamba. I'm the mayor of Milwaukee, and the climate is a big passion of mine. And as it turns out, apparently, it's a big passion for a lot of people in Milwaukee because it ended up being an important part of our vision. And because it ended up as a big part of our vision, the council made creating a climate action plan one of our 3 city goals this year. So we formed a climate action plan committee and we hired a consultant. After I'm finished speaking, you'll get to meet some of the consultants, but right now, would all the members of the climate action plan committee please stand and be recognized? So I'm going to give you a little slideshow, and I'm going to start out by telling you a little bit about me that you may or may not know, and try and give you some idea of why I care so passionately about the climate. I was a contract photographer for the National Geographic, and one of the areas I specialized in was underwater adventures. This stemmed from my early joy and fascination with the ocean and the grand majesty of all the creatures. The ocean takes up 2/3 of our planet, but in many ways it is still mostly a mystery to us. But the creatures that live there are magnificent, and in many cases extremely intelligent. This manta spent 20 or 30 minutes dancing with Chantal and I. Both those creatures and we humans depend on the ocean for our sustenance. The fragile, exquisite beauty that exists beneath the sea is unmatched on land. And our oceans and our actions are killing the oceans. Between what we dump into the seas, overfishing, and most importantly, climate change, we are killing the oceans. That vast, often unknown and rich body of life will be dead by 2048. In addition to all the other extraordinary life on this planet that we are losing, I have 3 more very personal reasons for caring deeply and working tirelessly to stop climate change. My kids. This is my son, Forrest, about 24 years ago, my daughter, Summer, and my youngest, McKenna, about 15 years ago. They're all young adults now, and the world we've created will be theirs to deal with. So this is Earthrise. It's the first image that most of us saw of the Earth. This image was taken on December 24th, 1968. They were looking for landing sites. They didn't land. That came 7 months later. These scientists were focused on the surface of the moon. They didn't expect to see this image. And one of the astronauts saw it out of the corner of his eye and said, "Wow." And then ensued a scramble for the camera and the film, and they got the picture. This launched the modern version of the environmental movement. Within 18 months of this picture being seen, the first Earth Day was founded, and the major environmental legislation was passed in this country, the Clean Air Act and the Clean Water Act. This is the first picture of the Earth fully illuminated that any of us ever saw. It was taken on the last of the Apollo missions, and it changed the way that humanity thought about our common home. It reminds us that we are all connected and that our actions have an impact on the planet. This is kind of the most important picture in the whole slideshow. What you see there is the bottom half is the Earth, the top half is space. The sky is not a vast, limitless expanse the way it appears to us when we stand on the ground and look up. In reality, there is just a thin shell of atmosphere that surrounds the planet. The thin blue line on the horizon in this image is the entire atmosphere. It's only 7 miles deep. So there are 3 questions remaining about the climate crisis. Must we change? Can we change? And will we change? First of all, must we change? The scientific community all around the world has been telling us for a long time that yes, we must change. Now Mother Nature is telling us the same thing. We are putting 110 million tons of man-made global warming pollution into the atmosphere every single day. That pollution, especially carbon dioxide, is building up and it's trapping heat. Here's the basic science of global warming. This has been understood by scientists since the 1800s. Energy from the sun comes to the earth in the form of light. That energy is absorbed by the earth and warms it. Some of that energy is re-radiated from the earth in the form of heat. Some of that outgoing heat is trapped by the atmosphere, which is a good thing. It has kept our planet at a stable temperature. Now, however, we have been thickening the atmosphere by filling it with heat-trapping pollution. More heat energy is trapped, and it's warming our planet at an unprecedented rate. There are many sources of man-made global warming pollution: industrial-style agricultural practices, forest burning, transportation, and many other factors. But the main source and cause of the rising global temperatures we see today is the burning of fossil fuels. Fossil fuels still provide more than 80% of the world's energy. Their use and emissions has gone up dramatically since World War II. Notice that in the last few years, though, there's been a leveling off as the world adopts more and more clean energy solutions. If you add it all up, the cumulative energy that man-made global warming pollution traps in the sky is as much extra heat energy as 400,000 Hiroshima-class atomic bombs exploding every 24 hours. As a result of this pollution being trapped in the atmosphere, global temperatures have risen dramatically. According to the National Oceanic and Atmospheric Administration, 2017 finished as the third warmest year globally since records began. NASA actually ranked it as the second warmest. This is the warmest year on record without an El Nino in the Pacific Ocean. 16 of the 17 hottest years ever measured with instruments have occurred since 2001. Heat affects not only people, but animals, crops, and our weather. According to the insurance industry, the number of climate-related extreme weather events has been going up worldwide. In 2016 alone, these disasters caused losses totaling over $175 billion. On a global basis, more than 90% of all the extra heat energy is trapped by our atmosphere is going into the oceans. This heat makes ocean-based storms like hurricanes, typhoons, and cyclones stronger and more destructive. In August 2015, 3 Category 4 hurricanes occurred simultaneously in the eastern Pacific Ocean, the first time that had ever happened in that basin. The extra heat also disrupts the water cycle. The amount of water vapor that evaporates off the oceans increases as the oceans warm. That water vapor is carried over the land and often falls in much bigger precipitation events. When the land can't absorb all the water that falls in these larger storms and downpours, we see floods and mudslides. This is Montana. You can barely see the barn on the horizon compared to the enormous downpour. The vapor in the sky is carried thousands of miles over land, and that extra vapor means bigger downpours. Warmer air can hold more water. For every degree Celsius of warming, the Earth's capacity for water vapor increases about 7%. An atmosphere with more moisture can produce more intense precipitation events. This is a microburst or a rain bomb in Tucson, Arizona in 2015. Extreme precipitation events have produced more rain and become more common since the 1950s in many regions around the world, including much of the US. By some estimates, the storm surge from Superstorm Sandy was nearly 13 feet in Manhattan's financial district. In 2015, the Kellogg Bridge in Milwaukie sustained significant damage to its footing during an unprecedented 24-hour rain event. Replacing the bridge is costing us $2.5 million. Torrential rains in Peru in March of 2017 triggered massive floods and mudslides across the country, displacing tens of thousands of families and killing at least 85 people. The amount of rain received was 10 times the average rainfall for the region, causing it to be labeled the worst flooding in decades. The country was forced to request international aid to help with reconstruction costs as well as for provision for survival necessities to families that were displaced. That's a pretty devastating image, I understand. She survived. But picture that happening anywhere, everywhere. Some people wonder how global warming can be blamed for causing more precipitation and flooding, and at the same time, more drought. The extra heat that's being trapped actually leads to both. And as the climate changes, precipitation patterns also change, leaving some places with less rainfall than before. Changing precipitation patterns can lead to drought and water shortages. Southern Brazil, for example, suffered a devastating drought in 2015 and 2016. High temperatures also have a direct effect on the incidence and severity of wildfires. Here we see that the number of large fires corresponds closely to the years with the higher average spring and summer temperatures. On September 7th, 2017, there were 78 large wildfires burning in 8 western states, including Montana, Idaho, Oregon, Washington, and California. The National Weather Service issued fire weather watches, red flag warnings, and air quality hazards throughout the Pacific Northwest as smoke and ash continually filled the sky as a result of wildfires. Even the Coast Range, which I think of as a very wet forest, was not immune. Wildfires are devastating not only to forests, animals, and air quality. They can directly affect our families and our homes. The fire season in the West is now 105 days longer than it was in the 1970s. This glacier in southwest Greenland had almost completely melted by 2013 due to rising temperatures. NASA has precisely measured the decline in the mass of ice in both Greenland and Antarctica. All this extra melting has raised sea levels worldwide. This flooding occurred in Miami Beach, Florida on a sunny day with no rain. High tides now regularly flood the streets of Miami Beach as well as several other coastal cities around the world. This situation will only get worse as sea levels continue to rise. Miami is the #1 city at risk in terms of assets at risk, followed by Guangzhou, China, and the New York metropolitan area. Looking at cities at risk by population, we see that many huge cities in developing countries are very much in danger. And if parts of these cities become uninhabitable, where will the people that live there go? The Department of Defense in the United States has long warned about refugee crises connected to the climate crisis, as well as pandemic diseases, water shortages, and food shortages. Heat stress is now beginning to decrease crop yields from rice, corn, and soybeans. Exposure to higher levels of carbon dioxide also decreases the nutrient content of many staple crops such as rice, wheat, and soy. Climate change, along with other factors such as ecosystem loss, is contributing to the worst extinction event since the extinction of the dinosaurs 65 million years ago. As of April 2016, a comprehensive survey of the Great Barrier Reef revealed that almost 93% of all reefs in the region had been hit by coral bleaching. In the previous summer of 2015, more than 2 billion corals lived on the Great Barrier Reef. Now, after 2 consecutive years of very warm water and massive bleaching, half of them are dead. Coral reefs are the nurseries for many, many species of marine life. A recent study that found that without significant change in human behavior, the oceans will be effectively dead by 2048. According to the study, the loss of ocean biodiversity is accelerating, and 29% of seafood species humans consume have already crashed. If the long-term trend continues, in 30 years, there will be little or no seafood available for sustainable harvest. The research also found that biodiversity loss is tightly linked to climate change, declining water quality, harmful algal blooms, ocean dead zones, fish kills, and coastal flooding. All of these threats, including many we haven't even covered here, and the fact that the World Economic Forum says that climate change is the #1 threat to the global economy, help to answer the question, must we change? So do we have to change? But what about the second question? Can we change? The answer to this question is very, very exciting and positive. And we've got the solutions available to us now. Look, for example, at renewable energy. Wind was predicted to provide 30 gigawatts of electricity worldwide by 2010. As of 2016, we had exceeded that prediction 16 times over. We see an exponential curve when we look at the amount of wind energy being built around the world. Wind could supply 40 times more electricity than the entire world currently uses. Solar energy is an even more dramatic story. 15 years ago, the best projection was that we would install 1 gigawatt of solar capacity per year by 2010. By 2010, we had exceeded that goal by 17 times, and in 2016, we exceeded that goal by 75 times. Even more dramatically than wind, we see an exponential curve in the amount of solar energy installed around the world. Just as we have seen with other technologies such as computer chips and cell phones, solar costs have fallen dramatically. In some regions, solar energy is less than half the cost of electricity from burning coal. In many countries where there's no universal electricity grid, we see consumers and businesses leapfrog over old technologies and install solar panels in places that have long been denied access to electricity. Chile is a true solar success story thanks to its policy decisions. That country's solar market took off slowly, but look at what's happening now. There are many regions in the world where this type of growth and development are possible. Every hour, the Earth gets as much energy from the sun as we need to run the entire global economy for a year. If we can increase the fraction of that we harvest and use, we can make a lot of progress towards solving the climate crisis and help local economies at the same time. On the way, we're creating jobs, almost 10 million now. Battery storage is an essential part of the green energy revolution. Batteries allow us to store excess solar or wind energy and use it during those times when the sun isn't shining or the wind isn't blowing. Batteries are also critical for the electric vehicle market. As storage technologies get more efficient and cheaper, the market is growing quickly. Within the next 8 years, highly efficient LED lights are predicted to virtually take over the market. Energy-efficient technologies like LEDs save people money and help to reduce emissions by cutting down on the amount of electricity we use. All of these automobile manufacturers are now offering or preparing to offer electric vehicles. This is another part of the sustainability revolution. Here are all the cities who have committed to 100% renewable energy in the US and those that are already there. So can we change? The answer is yes. What about that final question? Will we change? How many of you came tonight committed to change? Thank you. So, you'll be happy to know that the City Council is moving ahead. As this process has been proceeding, the Council passed a resolution to support this process and to give staff the surety that they needed so that our budget would be in place to have an employee to add to the staff as soon as we finish this climate action plan. So we will be moving immediately into action as soon as we finish. I think a lot of people wonder, okay, how much difference can a little town make, right? We can show that it's possible to do. We can show that a city can thrive, a small blue-collar city can thrive and address climate change simultaneously. So that's what you guys are up to. So I'd like to introduce our consultant, Josh Proudfoot, who will take you through the rest of the talk, and then you'll get a chance to go to work on making suggestions, making decisions about how we can best affect the climate in our city. Thank you for coming tonight.
Hello, everybody. My name is Josh Proudfoot. I am the project manager for the consulting team. We're very honored to serve the city of Milwaukee. Before I start, I just wanted to say that we have worked with many communities in the Northwest and around the U.S. And hands down, we have the most leadership emphasis on climate change in the city of Milwaukee of any of the groups we've worked with. So that's something everybody should be very proud of. That leadership means a lot, especially to other smaller communities. But what we like to see is the action moving forward. So in front of you is a graph of the earliest piece of work we did to start this process. So each color bar represents a different aspect of community and the emissions that come from it. Some of them are bigger than others, but generally what you see, let's see if we've got a pointer here, right here is where we are now for total emissions for the community. 250,000 metric tons, which sounds like a lot, but it really boils down to about 20 metric tons per person in Milwaukee, roughly. This line shows how with minor population growth, we'll probably see faster, that emissions curve would go up if nothing changed. What we did is we looked at all the policies on the books already and modeled how much of a difference is it going to make to the community's carbon footprint. And what we found is by 2035, those policies enacted will be about a 16% reduction. So clearly there's some work to do, but it's also exciting to know that some of it's already baked into the cake. Right here you see the state of Oregon's 2035 goal. So this is aligned with the Paris Accord. And you can see there's a substantial amount of emissions we need to go to keep up with the state of Oregon's goal. Now here's the shocker. This state of Oregon goal is about half of what we really need to consider. What's not in there is all the emissions that we import into our communities from the stuff we buy. Stuff that's made elsewhere, stuff that's not made in Milwaukee, stuff that's not made in Oregon, stuff that may be made around the United States or around the world. So this is the beginning of how we look at what needs to be done. So what is in a climate action plan? We have to divide it up because we can't take on all topics at once concurrently. So these are the topic areas we came up with. And some of them cover both mitigation, how to reduce emissions, and some of them are more focused on how do we adapt to the future that's coming rapidly at us. Building energy sourcing and efficiency, this is probably one that most folks know. When you think about the light bulbs, when you think about insulation, when you think about rooftop solar, those kinds of things, that's what's living in there. There's a little bit of adaptation. If you have a super well insulated building, whether it's colder or hotter, you're more comfortable without energy. Vehicle fleets and fuels is very much about emissions and mitigation. It has very little to do with adaptation. Land use and transportation planning, that's both. How we organize our communities, how dense they are, how easy they are to get from point A to point B, that's an emissions issue. But also, if we organize ourselves well, we're making sure that the natural hazards that can come later aren't going to be disruptive to our community activity. Materials purchasing, use, and recovery. This is the big sleeper that's not in the Oregon goal. This is the stuff we buy from other places. This is anywhere from 40 to 60% of the problem. This is, almost exclusively under household control. This is us. Natural resources, very much an adaptation challenge. What kinds of trees are going to thrive over time? What's water going to do? What's it going to be like when it's hot? What's it going to be like when it's cold? Public health and emergency preparedness is almost purely a response, to the natural resources and the changes in the natural world that are coming, but also the population. We're going to see a population surge in the Northwest because we have water, and we'll continue to have water, and we are going to have agriculture to feed people when great parts of our country will not be able to do that. Okay, so what's involved in a climate action plan process? So first of all, you're all part of it. Thank you for being here tonight. Where we started was with volunteers that were interviewed and selected for the Climate Action Plan Committee, and many of them are sitting at all the tables around tonight. They're residents, they're neighbors, they're business owners, they're the essential groups that serve us, like the school district and the utilities. It's the folks that want to change the community and the folks that hold the big levers. We've worked in multiple groups for them to shape a lot of what we're doing, but we also had these 6 topic area groups where we brought in folks that do just this stuff for a living to say, what can we do better and what are we already doing? So let me go through a few of the actions just to introduce you to the topics that we'll discuss at the table. So from the groups, these are just a few of the highlights of the things that we need to do to start moving the built world in the right direction. One is a community solar project. We have great trees in this community. It also makes it difficult to put solar on every rooftop. So how can we share in one? A building energy score program. In the EU, this has been very successful. It takes about a decade to get rolling, but essentially every time somebody goes to rent a house or buy a house, they would see, how does this perform? Almost like a food label, a nutrition label, and they'd know what they're in for financially. Microgrids and energy storage. If we get energy storage, we can go to cleaner and greener power. Without it, it's very difficult. Household strategies. This is what I like. There are things to do right now that aren't expensive, that aren't going to cripple you, that are going to make a big difference. Signing up for green power, signing up for Northwest Natural Smart Energy Program where the gas is offset. And then if you're a homeowner, considering solar or asking the ETO to give you a review of your house and what you can do. Natural resources, again, this is about what's going to happen over time as temperatures increase. Number one concern out of all of our groups, flooding. This community's experienced flooding. The river's going to rise with the sea level rise because it's tidal all the way to the falls. We're going to have to rethink stormwater in the community. And we know we need to increase the tree canopy because we need to provide shade to folks in the summer where by 2100, if nothing gets better or worse, we're looking at 12 degrees hotter every single day of the summer. So that's roughly like Tijuana's temperature regime. So by 2100, the city of Milwaukee will feel like Tijuana, Mexico. So those trees also need to be the right trees, the ones that can live in today and in tomorrow. So there's a lot of careful choices there. Here are some of the things. These mostly relate to homeowners, but as a community member, you could also participate in those. Again, floodplain, flood, big concern for your community. Cooling and air quality relief centers. How many people had a hard time managing the wood smoke last summer? Okay, we have to figure that out. That's something that you've heard of warming centers in the wintertime for people that don't have shelter. We need cooling centers and we need fresh air centers. By 2060, we should see 500% increase in wildfire in the state of Oregon. 500% surface area increase of what's burning. So what we got a taste of is going to go up 5x. So this is going to be a regular part of life we got to work with. So the traditional store water and food for events, that's always helpful, whether it's an earthquake or anything else. Knowing how to get to the most important places if there is a flood, another really important thing. And then if you're a homeowner, thinking about how you can keep your house cool in the summer. Again, here's the big one when it comes to emissions. What do we need to do? We need to stop buying new stuff every time something's broken. We have to fix things. I don't know how hard it is for you guys up here, but finding somebody to repair simple things often takes more effort and more cost than just finding a new one and buying another one and pitching something out. We've got to change that. We got to buy durable, we got to buy used. We need to make thrifting the normal process, and we have to do things like make sure our food waste goes to the right places. Also, this is not popular to say, but we need to eat more plants. What we eat matters. And I like meat, but I have to eat less of it because of what it's going to do for the world. And we also have to stop wasting. Americans discard 40% of all food that we produce. If we just cut out the waste, that's one of the biggest things we can do. Just stop wasting food. That doesn't mean you have to go to 800 pounds because everything in the fridge has to make it into you, but okay. When it comes to vehicles, it's what you would think. We want to get everybody into mass transit. We want to get people into EVs, and then really for everybody's health, when we can, walk or bike. It's a small community. It's doable. As you're growing, fill in those nodes. Help be part of the comp plan and plan a community where everybody can walk to what they need to get to. And then as you can, buy a better vehicle. Again, small housing, mass transit, walkability, things we know are good. And as a neighbor, doing the same thing and encouraging other folks to do it. Okay, so not everybody needs to understand every bit about temperature levels and parts per million, but essentially part of what we're going to ask you about tonight is how fast do we move? And on everybody's table, there's this graph, and as you see, nothing worse or better. We have mass population moving up here because it's more tolerable. I don't know if anybody caught it, but Phoenix had to shut down their airport for 3 days last year because their runway was too short. When it got too hot, the air was too thin, and they couldn't get enough thrust to lift. They couldn't get their planes off the ground. It's little stuff like that, bit by bit, that's going to make people move up here. The wildfire we already see, this is coming on some level, hopefully less than what we're seeing. But, excuse me, this goal right here is what the Paris Climate Accord goes around. We're already past 1.5. It's already starting to happen. And the way we'll experience this is Summer stream flows, so in the dry season, half of the water that goes down the rivers and streams now will be in those. So summertime is very hot and dry. Wintertime is going to be warm but moist. We have the same water over the year. It's just going to come down in a different way. No snow. It's all coming down in real time now. Okay, here's a map of downtown, and you'll see right here's the wastewater treatment plant and the riverfront park. Same thing over here. Here's where we are already past 1.5. We're past this time. We need to work backwards. This is what flooding is going to look like from sea level rise. You're going to start seeing parts of the edge of that park disappear. You're going to see more flooding into Kellogg Creek and Lake. And then if we do nothing by 2100, you're going to see a big part of downtown underwater, just from sea level rise. This is not during a big rain event. We're actually going to have the river breaching the banks. What's really curious is if you do the same modeling on downtown Portland, you see a lot of the urban core underwater. People are just waking up to this. So, again, will we change? What do we need to do? The essential question that's in front of you is, hey, how much change can we tolerate to make it safe? If you're going to try and bring it to a safe level, it means we have to do a whole lot of work as an individual, as a family, as a household, at work, and the government has to make big investments. It's not one party, it's not the government just doing it for us, it's everybody carrying a lot of water. So that is the big challenge for you guys, is to say, how much change can we tolerate to make sure that this community is what we want it to be? Here's our essential questions.